10.1. Okay? We're going to do 10.1 notes. Now, we have been doing lots of squaring things. Now we're going to kind of do the opposite where we're taking the square root of stuff. So it's important that you have your calculator out for this. It's important that you're listening. Your heads are up. You're paying attention to me. You don't ask me 6 questions later because you weren't focused. Your phone should be down. You should not be watching something. Okay. All right. So we have f of x equals the square root of x. Okay? I picked these numbers to do it. Why did I pick those numbers right there? Let's look at them for a second. Don't answer out loud. Just look at them for a second. Why do you think I would pick those? Raise your hand. Why, Jamie?
Because they each have a perfect square root.
They're each a perfect square root, right? What's the square root of 0?
0.
What's the square root of 1?
1.
What's the square root of 4?
2.
What's the square root of 9?
3.
What's the square root of 16?
4.
Okay. Let's plot those points and see our line. So we've got 0, 0. We've got 1, 1. I'm not sure. These are all supposed to be positive. I think the copy was bad or something happened. Okay. At 4, we're at 2. At 9, we're at 3. And at 16, we're at 4. Okay. So nice, pretty line right here showing that. Who remembers what domain means again? All the x's. What are all the x's? All the x's are above what?
0.
X is greater than or equal to 0. What's the square root of negative 4? There isn't one. Does that make sense why that's the domain then?
Yeah.
Okay.
So could you say all the numbers?
So, no, because you can't have a negative, right? Right. Let's look at this. What if I extended my table? This is just, we're pretending this is the top of my table. What if I did negative 4? What's the square root of negative 4? What would I have to write?
There isn't one.
No real solution. Okay? So all those negative 1 doesn't work, right? Because it's no real solution. Okay? They don't exist. So that's why my domain has to be, x has to be greater than 0.
Can we just write that?
Okay.
So that's always the answer.
Okay? All right. Let's see. We've only done one problem. What's my range?
Y.
Y is what? Or equal to 0. Okay. What are my x-intercept? Where does it cross the x-axis? 0, 0. Where does it cross the y-axis in this case? Okay. This is what we call, right here, this was what we call a parent function. It's like what all the other functions are based on. We call it our parent function. It's what we start with, and then we move things around to look at a different one. Okay? All right. The shape of a square root graph looks kind of like that. One-sided. I kind of draw it in so I think about it. So when you guys think about what a square root graph is, I often think of it as like one arm, right? You know, I always do my like y equals x squared, my math aerobics. This is like a curved one arm. Okay? Okay. So let's talk about 2. What did I throw in front of the 2?
A negative. So then all
Okay. So the square root of 0 is still
0.
the square root of 1 is 1, and then we times it by a negative, so it's a
Negative 1.
okay. Square root of 4 is
2.
put a negative in front of it, it becomes square root of 9 is
3.
so we put a negative in front of it. Square root of 16 is a
4.
okay. So let's plot those points. We've got 0, 0, 1, negative 1, 4, negative 2, 9, negative 3, 16, negative 4. So we're going,
So domain x is this.
okay, I would like you guys right now to try to say what your domain and range is. number 2. Well,
The x is greater than or equal to 0, y is less than. The x is so confusing that way.
what do we think our domain and range was?
So 0 is still going up, and then y is going down.
Okay. So, what are the x values? X is greater than or equal to 0. Now, the range is the y values, right?
Yes.
What's happening with the y values?
Less than or equal to 0.
See, you got it. And what is the x and y intercept still?
0, 0.
Okay, so the domain.
Domain is always the x, range is always the y, but let's see if they change. Let's go to the next one. Okay. All right. We're going to compare these. So, it's on the other page. So, instead of flipping back and forth, let's just write them down real quick. We've got 0, 1, 2, 3, and 4. Okay. So this is, we're adding 3. So what do you think we're going to do to each of these points?
Add 3.
Okay, so square root of 0 plus 3 is 3. Square root of 1 is 1 plus 3 is 4. Good. Writing these down too, what I'm saying? Square root of 4 is 2. 2 plus 3 is?
5.
Square root of 9 is 3. 3 plus 3 is?
6.
Square root of 16 is?
4.
Plus 3 is?
7.
Okay. All right. I have 2 different colors, so if you're using a pen and the person next to you is using a pencil, that might be helpful. Okay? Just an idea. I'm going to plot this first one real carefully. 0, 0, 1, 1. These, again, are positives. I don't know why it looks like they're negatives right there. Okay? We've got 4. We've got 2. We've got 9. We've got 3. We've got 16. We've got 4. So this is my original parent function, right? Here is my new one. At 0, I'm at 3. At 1, I'm at 4. At 4, I'm at 5. At 9, I'm at 6. And at 16, I'm all the way up here at 7. Okay. How does the graph compare with each other?
Move up the y-axis.
So it moves up 3. Okay, let's check. Alexis keeps saying she thinks x is always going to be greater than or equal to 0. Is that still true? Is my domain for the orange one still?
Yeah.
X is greater than or equal to 0, right?
Yes.
Still is.
Because only y is
Now, what is my range?
greater than or equal to 0.
Look at it again. I can't do 2. There's no 2 there. 3.
Oh, yeah.
You see that? You see my domain and range? I don't want to move on until you guys
Would there be
get
two
that.
ranges? So for this, are we only thinking of the orange line?
Just the orange.
Okay.
The domain for the orange line is x is still greater than or equal to 0.
And then we're going to do
But the range is y is greater than or equal to
Is that
3.
3 because you added 3?
because we're only comparing to that one.
So I don't know if you guys missed it. Like Alexis keeps saying these great things that you guys are missing. She said the range is 3. Is that because you're adding a 3 right here? I think so. Let's see if we can prove that that's true. Okay, let's go to number 4. We know these are all the same, right? Again, this is our parent function.
So the bottom one would have different, the ranges.
Let's see.
No, for the,
Yeah.
for 3.
Yeah.
Yeah.
Okay, so 0 is -4, right? 1 is -3. 4 is -2. 9 is -1, and 16 is 0. Does everybody get where I'm getting those from?
Yeah.
I just subtracted 4 from it. Okay? I am just going to graph this one. So I don't think we need the parent function for each one. If it helps, it's fine. At 0, I'm at 0. At 0, I'm not at 0. At 0, I'm at negative 4. At 1, I'm at negative 3. At 4, I'm at negative 2. At 9, I'm at negative 1. At 16, I'm at 0. Okay. How does this graph compare to my original parent function? Down 4. Let's talk about the domain and range for here. What's the domain? X is still.
Greater than or equal to 0.
What is the range?
Less than or equal to negative 4.
Wait.
Wait, what?
Is it? Am I just doing numbers
Why is-
below negative
No,
4?
why is greater than? That's what I was right. That's what I
Greater
thought.
than or equal to negative 4, right?
I was like, I can't get. It's not lower.
Okay. A number outside the square root shifts the graph up or down. This is called a vertical shift. Okay, ready for some calculator work?
No.
No.
Okay, is everybody on a graphing page? Okay. Looks like mine. I'm going to hit the square root, which is right next to the 4, x. And I get that pretty line right there. I'm going to hit tab,
What'd you type in again?
this right here.
Oh.
X squared.
Do you have to press tab? 'Cause I got the
If you
whole
press tab, another one will show up. If it shows up, that's fine.
Or
But if you're having trouble.
double click to work.
So I'm going to hit Control X squared, and then I'm going to put X plus 3, making sure that line on top extends, right? We hit enter. Ah. It moved left 3. That's what I want you to write down. Okay. Let's talk about the domain and range for it before we move on. What's the domain?
X is greater than or equal to 0.
Oh, look at it.
Oh, less than.
X, look at the orange one.
Oh, greater than or equal to negative 3.
Greater than or equal to negative 3. What's my range?
Ooh, that one's, it's 0.
Y is
Greater than or equal to 0.
okay. So, what did we figure out from here? That if it's on the outside, the domain stayed the same, but my range changes. If it's on the inside, my domain changes, but my range doesn't. Let's turn it over. Okay. See the picture? See the graph?
Yeah.
See how it moved to the left 3? So my domain is x is greater than or equal to negative 3. Okay? So when I am inside this square root, this affects my domain. When it's on the outside of the square root, it affects my range. Okay? All right. Let's see if that's true. We're going to plug these into our graph. I'm going to hit tab and then up. I'm going to change this inside here to negative 4 or minus 4. Do you see how it changed?
Yeah.
So it went from over here at 3, it moved over 4. So it moved to the right 4. And what's the domain?
X equals, X is less than or equal to.
X is less than.
Oh, wait.
Less than would mean it would be going this
Yeah,
way, right?
yeah.
It's going this way. So greater than or equal to 4.
And then
And what is the range?
Y is greater than or equal to 0.
Y is greater than or equal to 0. So,
I thought if it was on the inside, the range.
Range is the same.
if it's on the inside, the domain change.
Yes.
Outside, range changes. So a number inside The square root of the graph makes the graph move left or right, and this is called a horizontal shift.
So it's on the inside of the dimension.
Yes.
Word of the number
Say that.
What's the word? Oh.
Inside, left, right, horizontal shift. Okay. Average rate of change stuff. This is okay. So we're gonna plug each of these numbers in for the square root. So we're gonna say the square root of 0 is just 0, but this I'm gonna have to use my calculator. Square root of 0.3 is, I'm gonna just round to 2 decimal points, 0.55. The square root of 0.6 is 0.77. I'm just putting this in my calculator. I don't know this, guys. I don't have this memorized, okay? Square root of 0.9 is 0.95. Square root of 1.2 is 1.10, 1.1. We'll round up to. The square root of 1.5 is 1.22. Okay? Now we want to know the average rate of change. Do you guys see it all? Sorry. I said it, but I didn't show it. Okay? Now we're going to find the rate of change. Rate of change means we're going to use slope. Okay? That's like y2 minus y1 over x2 minus x1. You guys remember that?
Yeah.
Okay, so we're going to say 0 is my x1 and my y1, and 0.3 is my x2 and my y2. So we just say 0.55 minus 0 over 0.3 minus 0 gives me 1.833. That's my average rate of change. Okay, we're going to do the same thing for here, except now I've got 0.6 is my x1, y1, and 1.5 is my x2, y2. So that's 1.22 minus 0.77. Am I going too fast? Are you guys okay?
And then 1.5 minus.
Yeah. And you should get 0.5 as your answer. Okay, then there's more practice for your average rate of change. I just want to make sure we get to everything because we're going on time. I would like to move to 11. You good? Everybody's got the answers now at least for those? Just figuring out the slope. Okay. So instead of doing 11, let's skip to 13. Let's move down to 13. Okay, so now what have I added in front? So this is going to move it where? Right or left? Left, how many? 2. But this -2 is on the outside. When we think of, you know how we think of vertex form where it's a times x minus h squared plus k?
Yeah.
Okay, we can think of this as my h. That moves us right or left. The k moves it up or down. Except now we're doing a square root x minus h plus k. So what does the a do for vertex form? If I said, so if I said like 1/2, if I put a 1/2 in front of it, does it make it go wider or skinnier? You know, it like changes it, makes it wider or skinnier. So that's my prediction of what I think is going to happen here. Let's make a little chart to put it in. Okay, we've got x and y. Let's do the same numbers that we've been doing and see if they work. If we get decimals, we get decimals, right? We can do that. So we're going to say 0, 1, 4, 9, and 16. Okay, so I'm going to put it in my calculator. -2 square root 0 plus 2, and I get something crazy. I get negative 2.82. Okay, let's try it again, but instead of 0, we're going to place 1.
Wait, so we put -2, 1, square root of 1 plus 2?
I get negative 3.461. Okay, again, another crazy number.
I got 0.4641.
You're right. Sorry. I'm going to plug in a 4, and I get negative 4.8989, right? Let's plug in 9, see what we get. I get negative 6.63325. And I'm going to plug in 16. I'm going to get negative 8.4852. Okay. So, 0 gives me negative 2 almost to negative 3. 1 gives me just under negative 3.5. 4 gives me negative 4, almost negative 5. So right above negative. Number 9 isn't even on here. So we're going like this. Okay? Let's graph it in our calculator too. So I've got my parent function still in here. And now I'm going to change it to negative 2 square root x plus 2. Because I want to see what happens. Interesting. So this would keep going. And I would get negative 2. But I'm going like that, right? Okay. So my domain is now x is greater than or equal to negative 2, and my range is
Greater than or equal to 0.
that would be up here though, right?
Less than or equal
Less than or equal to 0.
Oh, wait.
Less than or equal to 0, right?
Yeah, because it's
Why is it 0?
So I know I stopped here, but when I looked in my graphing calculator, I wanted to see where it crossed the x-axis, and I could see it stopped right there at negative 2. Do you see it when I graphed it?
Range, yeah. But the range isn't on the x-axis.
The range is on the y-axis, though. Now look,
Yeah,
below the
and
y-axis, it's everything below 0, right?
Okay, yeah.
Does that make sense?
Okay, so it's like, okay, I see now.
Okay. So see how it stretched it? See how this is going a little bit slower? This went a little bit faster. See how it's further away from the axis kind of a thing? Okay. How about I let you guys do your homework? So this is your homework, 10.1 additional practice. So I've given you examples of almost all of these, okay, where you've got to test your domain and range, okay? Now remember, if it is inside the square root sign, what does it affect?
Inside is.
So if it's inside, it's going to affect your domain, right? If it's on the outside, it's going to affect your range, okay? So think about those. It's got you graphing some. So again, you can make a table if you want, or you can just adjust it around. We've talked about rate of change. And 8 is going to be kind of a little bit of a challenge because we haven't done any story problems yet. So I want you to at least write something for 8A and B. Okay, so I am going to stop the recording now.